look pretty much awake after lunch break. That's good. So first of all, I'd like to say a big thank you to the organizers here to bring about this crowd, to bring about this event, and for inviting also us, giving a presentation here. And the topic this afternoon is much more going towards sustainable developments, and therefore you see in the title of my presentation, we focus on industrial additive manufacturing. We know a lot about applications of our customers, and we know therefore you need fit-for-purpose materials. And now let's combine that with the idea to make them as sustainable as possible and as affordable as possible, therefore the business-to-business economics. I will speak here today a little bit about BASF so that you get a glimpse why we think when sustainability becomes a subject, we are pretty well placed. Then I take a look at additive manufacturing at the verge of industrialization, explain what we think is fit for purpose, and then I think I reiterate something, I build on something that was presented here before. It's collaborating for success, because none of us, nobody of us can do it alone. We have to work together. So about BASF, the purpose of the company has changed 10 years ago. And then we built on a strong record of innovation, and sustainability is at our heart. And you can see this here. Indeed, the company was founded 1865 and was, from its own understanding, a supplier to other industry verticals, to the chemical industry itself, and then to a lot of other manufacturing industries. But it was about a decade ago that we said, you know what, it's no longer important that you just create materials, that you just create things that are needed for industrial applications, but we have to do this in a different way. We have to rethink, and we have to create chemistry for a sustainable future. And when we say so, this is all built on a few pillars of the company. The company is huge. It's the largest chemical company in the world, and I only highlight here the first two bullet points. Our chemistry is used in almost all industries, and this gives us insights into all these industries we can then use for our product development again. And the statement is very clear. Yes, economic success is something that needs to be there for us to go and to strive and to continue our journey into the future, but it goes equally hand in hand with social responsibility and environmental protection. And that is engraved in the meantime in all our structures and processes in the company. So when we do innovation, it is of course that we want to be an attractive partner for our customers. And when they have a problem, they have no answers themselves for, that they seek the partnership with us, and we develop the solution together. And so we have the ambition to stay on top of the chemical industry through innovation, and make this a key driver for profitable growth, which is in an industry where you have lots of products that are there for decades already. We have a vitality index in our sales, means 15 to 20% of our sales are coming from innovation of the last 5 years. This is in this industry not the standard. We can build on a very huge research and development network. Internally, we have 11,000 employees working in R&D, but we also collaborate with lots of R&D institutes and startup companies outside. More than 500 of such partnerships we have there. We spend a lot, and as a result, we file a lot of patents. Now coming to the sustainability subject. This is a subject that became quite popular recently, but when you really take it serious, it means a lot. You have to always think ahead, and you have to take actions and not just talk about it. And therefore, I come to one example. We have developed a methodology by which we do what we call sustainable solution steering. So everything we have in our portfolio is checked whether it is state of the art, whether it is inferior or superior with regard to the overall, most of all, environmental impact compared to other solutions that are available. And so in this chart you see, of course, the commitments are along the value chain. It starts with our suppliers whom we talk to and where we apply a policy of sourcing as responsible as possible. And it ends up, of course, treating all the things we have in our hands in a way that we make the most out of the resources. So that is a contribution to that aspect. But at the end of the day, you have to change your portfolio. And this is a picture here now where you can see what that means. We have indeed looked at the 10,000s of products we are selling and have categorized them. When they are better than anything in the market, then they are accelerator products. When they perform like the industry standard is today, they are performers. And transitioners and challenged products are below that line. And when we started that program, I know exactly that the challenged products were between 5 and 10%. We have reduced them to 0.1%, means we stopped producing those products. We really took action, yeah? And this is now a tool which is at the heart of every researcher at BASF to make use of it. So whenever we develop something new, we compare it not only with regard to product performance, but also with regard to the overall sustainability ranking with existing solutions. Yeah? And now we even give a commitment that within the next 5 years, we phase out anything that is challenged. Coming to the topic of additive manufacturing. So let's focus on the challenges there were and the jobs to be done by all of us in order to advance. And we looked at the market challenges there, yeah? And one thing which is a bit disappointing, we thought that industrial additive manufacturing would evolve faster than it does. But we are still lacking robust and certified end-to-end processes. And that has a lot to do, of course, with the status of our industry itself, but it also has to do that there is a lack of engineers that can really design for additive, that can think additive, and there is kind of a hesitation, a kind of wait-and-see attitude with the end users. And there are reasons for it. I will come to it. One is business models. As long as the dominating business model is that of a closed business model, and we listened to a few presentations today again of representatives that have great solutions, technically great solutions, but they confine it in the application because the cost per part are still too expensive, if only not the consumables were inflated by so high a margin. These need to be reduced in order to make it real industrial. The opening has started, so we speak today more and more about semi-open business models. The wait-and-see attitude, where is it coming from? And I think one of the things is there are different technologies. Here we have a focus on powder and on metal in a certain way at this conference, but BASF developed solutions also for additive extrusion, for powder bed fusion, for curable resin formulations of all kinds. And I can tell you, in all of these technology fields, there's a lot of innovation happening. There's a storm of innovation, as we call it. And this makes, of course, also investments for our customers difficult. If you buy something today, maybe next quarter or so, there's a better machine out there already. So why should I buy now? That also supports a wait-and-see attitude. Yeah? And of course, it is getting more competitive. The establishment certainly realizes that there are a lot of hungry, very well-funded startup companies, some of them even being unicorns. And also the chemical players, more or less, the big ones, all come to the play in the meantime. And one thing, not so much surprising, but only probably with regard to speed, is the importance of China is really tremendous already today. Of course, it's the largest manufacturing hub. But in additive, it is also a strategic investment of the country that is behind, and therefore I think this is the market where we all have to play successfully in. Now, a few words about technology challenges, yeah? And here with Evonik participating, of course, in the powder field, for example, you have a very fantastic material, the polyamide 12, that is so versatile, it's very easily processable, and it has expanded its application space because of this uniqueness to some degree, but also to the lack of absence of, to the lack of presence of availability of other materials. So we feel obliged actually to add a few polymer families to it. In the polyamide field we also play with higher temperature polyamides, but polyurethanes, TPUs in particular, polypropylenes and these kinds of materials have also to be made available because they are important industrial materials. And if we aim at industrial applications, we have to come to these material classes as well. We then have to find ways also to mimic somehow what you have in injection molding materials. Glass fiber reinforcements of up to 50% is the norm for engineering plastics. And you can't do this one by one in additive, and there are a few interesting technologies available, but I think the breakthrough is not yet there. Printers have simply to become much faster, much more robust and much cheaper. Stop. Full stop. And then again I mentioned we have to show and demonstrate that we have end-to-end solutions, that the customer does not have to develop a lot himself in order to really produce parts, but there is a complete chain, a digital workflow worth to be named Industry 4.0. And then a few words were mentioned on it, but it's about certification, it's about establishing standards, and all of that is also under development. And with digital data being behind it, it is also how to safeguard IP, how to work with this, how to make sure and to identify who had which contribution in making of parts. Okay, and then I think Singapore is very well placed. You put a lot of effort here in Singapore on developing young engineers, designers, and so that are able to really make use of it. And I think this is a very much forward-looking initiative I can only congratulate you to. We ourselves have a very simple strategy. We want to be a solution provider to our existing customers, so they know us.
Dear ladies and gentlemen, the Global Manufacturing Industrialization Summit Connect Asia Pacific will begin shortly in Hall 2 Workshop A. Kindly proceed there now. Thank you.
So they know us for decades because we develop solutions. Just the example of the automotive industry, our company has a turnover of more than 11 billion euro with the automotive industry. So we are by far the largest supplier from the chemical industry to that very demanding industry. And often we are asked, why do you do this? It's a very cost-sensitive industry. And the answer is simple, because they drive us to innovate. Only if you constantly reinvent and re-innovate, you have solutions that are attractive enough so that you can do big business with automotive companies and still be a profitable company yourself. And so we do this, and now we approach everything in a way that we normally look at the application first. What is the application? What are the requirements for the application for the whole service life of a part? And from this we derive which material or materials could be the best possible solution for this. Also again, if you design properly for that you make as efficient use of any kind of resource you put in there and come to a part that performs exactly as needed. And that is rethinking additive manufacturing, not having just one technology platform probably. I have this one printer technology, and on this printer technology I can run, we have seen it, a handful of products at best, and then I look for applications. No, we look from the application, and then only decide which technology shall be used. And so this is something, it's really a history in our company, and I go that far, that's in the next slide. It's why I joined BASF 30 years ago, because it was the driver of application engineering in Germany at that time already. And yeah, I can only say there's a lot of this in our DNA. And for this, we also develop solutions beyond just materials. You see it here that we have, of course, we use what is the best available kind of software for computer-aided engineering. But we add to it a few in-house tools. We sometimes say it's a little bit of our own magic. And with this, we can describe the material behavior during processing and in the service life a little better than most others. And this again qualifies us for being a leading partner of choice for our customers when it really becomes challenging. Now, collaborating for success, enabling industrial additive manufacturing. What does it take? First of all, attitude. It's all about attitude. You can speak a lot, and there are a lot of books written about it, how to successfully collaborate, but it's really about mutual trust. There should be a win-win somehow, complementary capabilities, and I mention it here with this, it should feel like a virtual joint venture. Sometimes even a joint venture is being formed, but there are also successful and not so successful joint ventures, you all know. And a few examples for this. When we talk about this here in the additive space, then we prefer to have three-way partnerships. So we come in as a material formulator, we have a lot of tools at hand to optimize materials, and also with the engineering services around it. Then you have the equipment manufacturers. And there is a wish I have to this community. Yes, we need to tune our materials so that they are processable on your machines, but I would also like to see the development in the 3D printing industry, like it was in injection molding, extrusion and so before. The machines have to become much more versatile and adaptable to the materials, because only then we can truly design for performance of materials. And thirdly, of course, we have the service bureaus. They have a lot of know-how. They make so many different products for so many different customers, and for them it's also an opportunity, of course, to get to the latest and always have a pulse check where the industry is. And a few partnerships I'd like to mention. On the second generation multi-jet fusion of Hewlett-Packard, we have qualified an ultra-thin TPU powder. And the first feedback from customers that were using this technology, or also from end customers receiving the parts, is overwhelmingly positive, so that we see this is a new material for the powder space that will have its market. Another area here is the additive extrusion with filaments. And Essentium is here our partner for a number of years, and Essentium originally was a material development company and turned into a solution provider, also offering own 3D printers that are designed for industrial applications. From the beginning, the masterminds behind it, they come from manufacturing industries, they come from very fast processing manufacturing industries, and they want to see very fast processing of materials. And when this platform is now just becoming commercial as we speak, it already starts with a set of materials that is broader than the industry standard at this point in time. So, and there's a lot of engineering materials behind it. And just one customer example here from the Toyota Group, there is already a relationship to build factory floor solutions, tooling, jigs, fixtures, all of this with carbon fiber reinforced polyamide filaments. And these are just examples, selected offerings of what we have already available today. So, of course, we are also, like Yvonne mentioned, in the chemical industry you deal on several stages of the value chain. So we have raw materials that other formulators use. We also produce filaments ourselves, yeah? These can be polymer filaments, but we also have metal composites, like Desktop Metal talked about, or Mark Forsch talked about. These materials are also available from us. Preferably we supply them to semi-open or open platforms very clearly, because we think with this way we can make them available at business-to-business economics. And then we have the powders I mentioned and the curable resins on the material side. Services that go around it is, of course, own design skills that we also trade to our customers, how to manage data. The application engineering is probably the most important, because I just take the example of injection molding. The injection molding machine, the modern injection molding machine, was actually developed at BASF 1938. And at that time we also built the whole ecosystem of manufacturers and users. And later on, when the business was big enough, we reduced our role to materials and engineering services. And we see pretty much the same need for the additive world, so we collaborate with a lot of equipment makers and software producers and so to enable the ecosystem really becoming industrial. Of course, it is, as I mentioned, when we look from the application, we help them in the material and in the process selection by the customer. And we have a lot of internal products and know-how about surface treatment and an old coating company, where indeed, for example, for the TPU powder, immediately we can show solutions that do not end with just the printed parts. For the metal filaments, at the end of the printing, you have just a green part. You need debinding and sintering. We do this with partners. And so we can help here the customer really to demonstrate what kind of products he can get. And we will also expand a little bit our prototyping and own additive fabrication capability, because we have learned that it is important for the acceleration of and the adoption of 3D printing in industrial applications, that you really have to take a stance there and show it simply. Yeah? The other things I think are natural: qualification, certification. That is also when you engage in application engineering, that only is successful once it is certified. And of course then we consult. And a little bit we do also, because collaboration is so important in this industry, we even offer contract R&Ds to other players in the ecosystem. Now, results of sustainability solution steering already on our small, just starting 3D printing solutions business. And yes, we offer where we have already, let's say, for example, extrusion weights or injection molding weights in this field. We use the very same approach, and we use bio-based or recycled raw materials. Yeah? And some of them are coming from closed loops already. Then when we look at powders, recyclability is a big topic, and we will only stop our development once we have zero production waste. When we go into UV curing resins, we had to learn that there are a lot of resins in the market that do not fulfill high regulatory standards. You will not get such products from BASF. We will always look that they are in line with the toughest regulations in any country in the world. Yeah? So you can be sure that if you use those products, also your workers work safely and the products will not harm end customers. Now building supply chains. One of the promises of 3D printing is that we can produce local for local. But very often this is reduced to the point where the printer stands. We believe it has to come also with where the production of the material is. So at least in every region, we need to be present and cannot ship from one location to the rest of the world. So we aim at that one, and wherever we can, we try to combine it with the Verbund side concept. Verbund, for BASF, it's the heart of our manufacturing concept. It is to combine several things into one and use the byproduct or the waste product of one process as a feedstock material for another process to increase resource efficiency. And now we do this more and more also with circular economy solutions. So we are closing loops here where we have collection of pure materials, be them from production or after service life. We are looking into solution, for example, to crack down the polyurethane in a way that we can make new polyurethane products out of it that have absolutely the same properties as the original material had. Or we would be very willing and able to feed large volumes even of plastic waste that has never been produced by BASF, but we have the cracking technologies in order to make it a viable feedstock. All of this we do. We call this chem cycling. For polyamides, another route is under development. And all of this will contribute that we will have a much improved resource efficiency and more really examples for circular economy solutions. And this is all supported by eco-efficiency analysis, where BASF also started actually when I was just starting at BASF 30 years ago. It's not something we are just doing for the last few years. That is a methodology constantly being further developed and used in-house for that long. Now, why I stay here and say we can do a lot together, I have to say we can't do everything at a time. So we are really looking at lighthouse projects. We will conduct 2 major sustainability studies where we compare additive manufacturing technologies with conventional technologies in the next couple of months, and we'll be happy to report about that once these studies are finalized. They come from the consumer and from the automotive space, and I'm more than welcome to go the journey with you and enable additive manufacturing that it becomes really industrial and that it contributes to sustainable solutions for a better world of tomorrow. Thank you for your attention.